Okay, today on the bench we have a faceless radio. So actually this is a realistic, grab the faceplate here, it's a TRC449, so AM sideband. Probably my favorite, well not probably, it is my favorite unit in chassis. So this is a UPD 858 chassis. Customer sent this in, not the first radio I've worked on for him, and actually I've got two that I'm working on for him right now. Basically hasn't used them in, I guess, decades. Wants them brought back up to snuff, digging them out of storage. So basically do any maintenance that needs to be done to them and get them in good working order again. So as with another radio that I did for him one time, he's also an amateur radio operator. He had done a channel modification to it. The other one was, I think, a base station. Don't remember what model, but it was a base station. But he did the modification the same way. Like I like to do, if you're going to do a switch mod, I hate reusing switches, drilling holes in the radio. So he used a little switch box. So great, no holes. So I fired this thing up, hooked it up to communications test set, put it in channel 20. Pick a close to the center of band channel. The way it looks, it's like his other radio as well. When all the switches are down, that should be your normal CV channel. Key to microphone. And I had my span on the spectrum analyzer set to like 10 kilohertz, one channel, and there wasn't anything there. So I widened it out some, and yeah, sure enough, I finally found it. And I just cannot get the channels on. So honestly, without contacting the customer, I'm not even sure if this thing was set up to do CV channels. I'm assuming so, because I'll have to get the cover unburied here. Sitting underneath the speaker platform, which, yeah, could probably use a speaker too. It's got a bit of a hole in it. Still works, but yeah, I'll ask him if he wants a new speaker or not. Like I say, it does work. But the reason I say I'm assuming it's still in the CB band is because you can see and you can just tell by looking at this how old this chart is. Yeah, it's getting yellow. So yeah, this thing has been on here for decades. Glare is killing me on this tape. But yeah, you can see CB channels. So, he had on here how to get to the A channel. So 3, 7, 11, 15, and 19 A channels. And then, what do we got here? I'm trying to read around the camera and it ain't working. Yeah, switches and then selector. Okay, yeah. So, which switch is supposed to be up, and then the channel position. So the channel selector. So the first thing that I noticed when I powered this up, like I say, did come on, did receive and transmit, not on the correct channel, but the first thing was I couldn't see anything on the channel selector. Barely. I mean, there'd be like a digit here, and a segment, like one here, and one here, and that was it, like maybe 3 segments. Go to turn the channel selector, and man, you needed all but a pair of channel locks to turn this thing. It was tight. I mean, tight. It's like, wow. Afraid I'm going to bend the shaft or break the knob tight. So I've removed that. Now, this uses a flat flex circuit board. Like a lot of these radios, the UPD, actually all of them, the UPD 858 chassis, they have a ribbon cable or a flat flex cable socket on the board right by the PLL chip for the programming from the channel selector down to the PLL chip. And that flat flex cable also comes over, and that's this little flat flex cable right here, comes over to the channel display. They're known for having bad circuit traces that they'll actually break. And this one apparently did have one broken trace because there was a wire that came up off of the board here and was soldered to the channel selector switch because one of the traces had broken. So I pulled this out, and yeah, it just was tight. So I dismantled the switch. I don't know what in the world happened to this poor thing. So normally you'd have 3 sections of the switch, and these can be taken apart and serviced. I've done it several times in the past, so nothing fancy here. You just have 3 gang sections, and of course, depending on what section and what they're used for, because the switch does 2 things. It programs for Pete's sakes, get down in there a little section. I'm not going to get it in because I don't have the switch discs in there, so they're kind of wobbling wobbling around there. But anyhow, you get the idea. All the sections go down in here. It looks like that when you're done. But you can take these apart if the fingers get, lose their spring, which can occasionally happen. So if you've never seen inside one of these, there's what's inside. So each section has a disc. Now these use a number 16, 17, and 18. So we have 3 discs like this, and they'll look different on each side, and each disc is different. And somewhere on this disc, this one is a, This is a number 18. You can see there's a little 18 right there. And identifies the different styles of discs, because this company made several different ones. And depending what discs you stuck in each section, and then which sections you used, would come up with different combinations. But anyhow, the disc section goes in here. So there's one of these gets sandwiched inside of each one of these. Now, like I say, you can take these apart if the springs start to lose their finger, if they get extremely dirty in there. Now, the discs, you'll usually not have any problems because, as you can see, they're gold-plated, so it's not going to oxidize. That's why they use gold. It's oxidation-proof. The fingers, like I say, can lose their tension. A lot of times you can retension them. But that's not going to explain why it was tight as heck. Now, when I removed the whole thing out of here, I noticed this black thing on the front, and I was kind of like, it didn't really dawn on me. I'm like, I'm not used to seeing that there, but I was like, maybe it's supposed to be there. I don't know. And then I got to working on it and tearing it apart, and when I got to this section, which was the frontmost one, which is behind, the mounting plate, so this would have been like this, right here. Okay, shaft goes in, then that horseshoe bracket on the back would wrap around, and then these 4 little ears, they get bent over, and that's what actually holds the switch sections together. And then this little bracket goes in behind this nut, and that's what actually screws to the front of the radio with the 2 screws down there. But, like I say, I got it apart this far, desoldered all the sections off of, one of these. It doesn't look like this one, the one that's in here. It's different. This is another, because I had to replace the switch. But it looks very similar to this. Actually, this end's the same. The traces will look a little bit different here. The only difference is with this one has 2 built-in dip package resistors, so dropping resistors for the display. But the switch is the same, and that was the key, so that's why I used that switch. It had to salvage it off of this board. But what's happened to these things is, as you can see, it's very thin. It's a flat flex circuit board, and the traces break. It's just plastic with these little copper traces on here, and they can break. It's very common. These things get flexed too much and tinkered with. But that wasn't... I did see 2 broken traces, one that had been fixed, and another one that needed to be fixed. But that's not going to cause all those segments to go out, and it's definitely not going to cause it to be hard to turn. So after I got this section apart, I got to looking at the disc for it. And I don't know if it'll even show up in the camera. You can see how the disc isn't perfectly smooth there. There's like a slightly, in the camera, I guess it looked a little bit tarnished, or it's not really shiny. And on the back side here, down here at this bottom edge, you see that stuff? That black thing is not supposed to be on there. I didn't think so, but I wasn't sure. For some reason, that was glued on. I don't know why. And the glue, whatever they used, oozed in. So you can see there's some down here. I think there's even some in this section here, down at the bottom. And the glue got all over this disc and all over the contact fingers. That's the reason. And now that was making it lose contact. So, the sections weren't making contact. So that was what killed that. What was making it turn hard was the glue also got in from this direction into the shaft. So the shaft, this, that goes through. And if you look on the shaft, you can see there's a bunch of grungy, goopy stuff on there. That's that glue, and that's why it was hard to turn. This shaft had effectively been glued inside of the bushing that it's supposed to turn in. And then on top of that, I could have cleaned all of that off and probably got it working. But then to make matters even worse, so here is your basically notch disc, I guess you could call it. So, when this is in here, there's actually a ball bearing. This little guy right here, the ball bearing, is supposed to sit in that pocket right there. And then the ball bearing now on the other side here touches these little teeth. So the ball bearing would be in there, and that's the ratchet. Well, that was another problem. When you turn it, you could wobble the switch back and forth within its notch. And the reason you could is because, you see that? it's loose and wobbling around. So yeah, it got to the point where it just needed to be replaced. So that's what I did. Took it out. I don't even remember. I think this might have been a T-Berry. I had it written on I always write it on anytime I remove these. Had it written on the channel slide. I think it was a T-Berry is what this actually came out of. But I got a good working channel selector switch. Put it in. Actually serviced it. I didn't disassemble the switch sections, but I did pull this front section off. Cleaned out the old grease and off the ball bearing and everything, and applied new lubricant. So yeah, nice, easy, free working channel selector now. And you can see all the digits work just fine. So yeah, we're good to go there. So now I put it on channel 20. All switches down in that little switch box, and I'm still not on channel 20. And the channels are just, they're all over the map. So I don't know exactly how this thing is wired for the channel selection. So the first thing I want to see is the PLL chip getting the proper programming. So if you ever have a problem where your channel selector works, when you change channels, you've got the channels change, but there may not be on the right channel. And you've got a channel modification. So you've gotten a used radio, you're not sure how in the heck they got it wired up. First thing I always tell people, service manual. The SAMS manual, and in some cases the factory service manuals will have it, but the SAMS manuals, one thing I really like about those was all the radios, they always had the truth chart for the PLL chip. So they tell you the programming for that, and they also tell you the frequency mixing scheme for the radio. So that's the first thing I do, is I go to the SAMS manual, and we can see here's the truth chart for, right there, realistic TRC449. So, now like I say, I could pick any channel. I just picked channel 20 because that's for the center of band, so that's the one I'll usually be testing a radio on. And what I want to do is check the logic level right here. So now there's actually one pin missing, because if you count across, you can see 13, 14, 15, 16, 17, 18, and it jumps to 20. Pin 19, if you go back to the schematic, is permanently tied to ground. So that one is always going to be at logic level 0. And that's another thing you'll find on the truth chart, is 0 is 0 volts, and 1 is going to be, now it's not going to be exact, but it's going to be around 4.9 volts, 4.6 to, something like that. So, a 1 will be over basically 4.5 volts, and a 0 should be at ground potential. So, I just wrote that code. Now that, yeah, it's backwards. It doesn't go 13 to 20, or 21, they have it written backwards. But I just transposed that then onto a sheet of paper, something that I can easily just plop on here. But so this is what I should see. So I should see from pin 13, a logic level 1, and then, and we just went out of focus. Focus. 0, 1, 0, 1, 0, 19, I just wrote tied to 0, because that's always tied to ground. That one's a hardwired. It does not go to the channel selector. And then 0, 1. So you can use a voltmeter, but it's very handy using a logic probe. So actually, you can even see me just touching the probe. They're very sensitive little critters. It's sensing a logic level. But all this does is basically it's going to read either a low or a high. Low, ground, high is the voltage. So it's going to be, and I just have it tied into the voltage source right at the PLL chip. So ground, and I just have a little wire tacked onto that pin, which is pin 12, which is the supply voltage for the PLL chip. And that's what I have so this is the power supply to the logic probe. And then all I have to do is go through here, and it will show a low for 0 or a high for 1, on this chart. And what I want to see is just that. If I don't have that, then I know the programming is wrong, and it might be one of my switches. So yes, this radio is, shall we just say, slightly hacked up. Yeah, there are actually a lot of modifications. Now, a lot of the modifications are factory service bulletins. So, a large majority of these parts on this radio, the capacitors, the diodes, a lot of this stuff, that's all factory revisions. When they first came out with these boards, there was kind of like a rush job, and Cobra was the one that got stuck with those, because Cobra had the early order in for this UPD 858 chassis. And they had a lot of problems. So there's like a dozen or more service bulletins for this chassis. all of the other companies that got these boards from Uniden didn't have that problem, because by then Uniden had already, some of those boards, Cobra released the radios, there were complaints, they came up with bulletins to repair all those, and then so like Realistic and everybody, when they eventually got their boards to build their radios, all of the service, the technical service bulletin modifications were already done. So that's what most of those parts are. But there's other stuff. I can see like the driver had been replaced, and I'll get into that later probably, but I can see leads sticking up here, there's parts missing, the clarifier is unlocked, there's traces cut. A lot of this is for broadbanding, picking different input and output taps on some of these transformers, but yeah, there's stuff all over the place. But it does work, just not, I can't get the CB band where the CB band should be is my problem. So that's what I want to troubleshoot. So, get this folded over actually, try and get this on camera view. So that's what we want to see. Yeah, that's all in view. So all I'm going to do is take my logic probe, and I want to touch to each of the pins. So the first pin, we're going to be counting from right to left. The first pin in this row is pin 13, so that should be at a high, or logic level 1. And I touch it, and well, immediately I see low. So there's a problem. And I'll come across, so I should have what? High, low, high, low, high, low. So that's wrong, because that should be high, low, right, high. Wait a minute, I can't even, I'm trying to see around the camera here. This is really hard. Don't have enough light. So high, that should be low. Actually, now that one, aha, toggle switch got flipped on the box too. It's not helping matters any. Okay. I should have 13. Is that one? Or no, that's 14, 15. Okay. 16, 17, 18, 19. There's 19, looking good. Over here. 20. No, it's not 20. Where is it? That's that black wire. Yeah, low. And 21 should be high. Yeah. So it looks like the only pin that's wrong is pin 13. It should be at a logic level high, and it's at a logic level low. So now what that gives me is a bit of an indication why it's wrong. And actually, let's see. Let me turn the radio off. So what do we got? 1 0 0 1 1 1 0. We're showing a 0. So yeah, and that, or no, I'm at the wrong one here. 1. Same. We're back 1. Actually, that's not. So it would be 0 0. Yeah, which is actually not on here. Because what we have right now, the way it's programmed, would be 0 0 1 0 1 0 0 1. So 0 0 1. Just looking down through here. 0 0 1. 0 1. No, that's going to be different. Yeah, so that's why it's not on a CB channel that's currently programmed. So, and there's this stuff here, so what I need to do now is to troubleshoot this a little bit farther. I need to take this black tape off, see what the heck's underneath of here. I need to trace out these wires. So the other wires, all these other pins appears to be fine because those logic levels are at the correct state when all those switches are flipped down. But for some reason, pin 13 is at the wrong logic level. It should be at a logic level of 1, and it's currently being pulled low to ground. It's not getting the voltage that it should be. So I need to basically trace out this one wire. Actually, the first thing I need to do is, because there's 2 identical cables, I need to find out which cable this is in that switch box, then trace out this white wire, and see what's in here, because I think there might be a resistor or something in there, because it looks like this also comes over to the ground trace. I just can't see anything because of all this tape. But so I just wanted to show that a little bit. It's very simple. You don't need a logic probe, okay? This is just an easy way of not having to look over there at a voltmeter. It's why a lot of times when I'm doing this type of work, I really like using a logic probe. It's very simple because it keeps everything within your field of view. I don't need to look down here, probe, and with a, let's say this was a voltmeter, so it didn't have any of these lights. It was just a tip, but I'm not putting it in circuit, and then I have to look over there at the voltmeter to see what the reading is. I can just look here, and it's right there. It's always, the high-low lights are always in my field of view. So, like I said, I just like these. They're very handy, and you can pick these things up brand new, cheap. You can get them on eBay, used, very cheap. This one's actually comes with a really nice kit. Also came with a pulsar probe and an IC clamp that identifies all of the pins. But like I say, the probes are really handy if you're going to work on this type of stuff and troubleshooting. That's where they really come in handy when you're troubleshooting, checking logic levels. And as you've seen, some of the older radios did not even use a separate PLL chip. They used separate ICs for the programmable divider and a lot of the other circuits that these more modern PLLs did all in one IC. Or like if you work on old frequency counters, these are indispensable if you're working on the old like Redco, or actually any of the old CB inline series style of frequency counters that just went in line with your antenna connection and took a small sample off. Those things can be full of dozens of logic, either CMOS or TTL series style ICs. And these are really, really handy, because these will do CMOS, you can actually see on there, CMOS and TTL, so it has positions for both styles. But so let me get some unwrapped. I'll do a little bit of troubleshooting, see if I can actually get this thing, actually find the CB band, because that's the problem right now. I can't get all of the channels. Now it's the only thing that's throwing off are the channels that should be at 1 on pin 13. So so that means this channel is going to be wrong. This one, this one, this one, this one, this one. Anywhere where you see a 1 in column for pin 13, that channel was wrong. And that's what I was seeing if I keyed the microphone and just continued to turn the channel selector, I'd see the frequency jumping around like this on the frequency, on the spectrum analyzer, because the channels were just all over the board because of that. So, in any case, let me do some diagnostics. Not so much diagnostics, but tracing out and see exactly how the heck this thing is wired, because apparently something is wrong. And I'll be back, and then we can get into some of the other stuff on this, and actually I can get this nasty old switch, and all these parts off of the bench here. I've already done some glue removal. As you can see, all the old boogers are all over the bench here. This is the glue that was on the bottom of the board here. So again, that's another easy way to tell that if a part is a factory modification, it'll have the old corrosive glue on it, because what they did was put a blob of the glue underneath of there, and then they'd fold the capacitors down. It really doesn't need it. It's not like you're not launching this thing into space on a rocket ship, so it's not like it's experiencing 40 Gs. But yeah, just pull up the caps, remove that glue. Now, it does not hurt the capacitors themselves. They're either ceramic or polydip, but this glue, as it gets, like some of this stuff had started to turn dark brown and corrosive, it will corrode the solder, because that's a non-ferrous, tin lead composition. If it's touching the leads anywhere, it will corrode the leads. It'll corrode the circuit traces eventually. So yeah, got that stuff. Any of the glue that was on the bottom, that's already been removed. So I'll still need to remove the glue on the top. And yeah, you can probably see there's some other modifications here that aren't factory. Like there's a wire that all of a sudden appears out the middle of the board here and goes back. I'm going to assume that is probably the clarifier unlock. Just looking at it. Yeah, I think that's the terminal you'd normally, which I don't know why it goes, I don't know. Lord only knows. But yeah, that's probably the clarifier. I'm not sure why they're coming up through here to do that. Yeah, that's, some of these jumper wires, these definitely aren't factory. There's Looks like there's a part missing there. There's 3 terminals that don't have anything in them that there should be. There'll be some empty holes. That's not uncommon. A lot of these, but you can see these. I don't know if you can see it in the camera view. Get it down here a little bit. You can see these are nice and shiny and obviously original from when this thing was wave soldered. But these down here, these have been, there was something in there. So, there's parts missing. Now, a lot of this, actually, let's see, flip the radio over. No, they'd be back. And that wouldn't be clarifier. I'm not sure what the heck they were doing. So, yeah, I'll have to do some diagnostics. I do know the limiter circuit's disabled and that's something I never leave in. Customers don't have a choice. If the radio is going to leave my bench, the AMC and ALC circuits will be enabled. I won't let that something like that go, because I've shown time and again that just splatters all of you. You're not gaining anything. It's all extra energy elsewhere in the band. But so let me get to it. I'll be back. Hopefully, when you see this next, see me working on this next time, it should be on channel. I should be able to get the CB channels. I'll have this switch box mapped out. And then I can get to recapping the radio, taking the glue off the top of it, and see if there's any modifications I need to undo. Like I say, I know I need to undo the limiter circuits. A lot of this other stuff can stay, because it has the channel modification, and the customer wanted to leave that. That's actually beneficial because it's broadbanded some of the circuits, because these transformers, like I say, they have multiple taps, and you're changing from a lower to a higher, or from a higher to a lower impedance tap. You can change how well that circuit broadband, so all of those will stay, of course. But so I shall return. Okay, so a little bit more sniffing around here, and as you can see, the channel selector is back out. So, like I said, I had to reuse this flat flex circuit board, because that's actually what this is. It's a circuit board, of a kind. Because I couldn't use the ones that I have, because they have this built-in resistor network, and then this is too long. You'd have to bend this literally like at a sharp 90-degree angle, and then a 90-degree angle again, and you'd break all the traces. You could possibly use this. They say, you remove the resistor networks and just bridge across, but it's too long then, and yeah, it just wouldn't work out. So I had to reuse the original one. And as you'll see here, it's potted in that. What that is hot glue. Now, I did that to prevent any further problems here, so this board can't move anywhere where they'd normally break. Because usually what happens is, these things are fine. There's radios I've seen these in, have been used hard. Boards, these flat flex boards, they're like brand new, because they've never been taken in and out, in and out, in and out. And that's the problem. You do modifications, these things get taken in and out a lot. People aren't careful with them, and you end up breaking the traces. And that's what had happened to this one. So it had a broken trace right here, and there was actually a chunk of the trace was missing, and there was another one over here. So you can actually solder this stuff. It's not, don't think this stuff is like really, low at a fairly low temperature it's going to melt. You can actually solder on this stuff. I mean, obviously it's soldered here. So, it's some type of, whatever type of plastic. It actually reminds me of, the kind of tape I use when I'm doing, surface mount repair, the polyaramid style tape. And that may be what type of plastic that is, which is very high heat resistance. But, so, I did not have a logic level 1 at pin 13, which would be right here, when I was in, channel 20, which it should be. So I pulled this out, still left it plugged in. I took it out and then plugged the flat flex cable back down into the flat flex connector board here. And yes, you can see when this mod was done, even 2 of the pins were pulled out of the board and go to toggle switches. Not exactly the best way to do things, but if it works, whatever. I didn't do it, so it is what it is. But I pulled this back out, so I again hooked my logic probe back up and checked at this terminal. And I pushed it in through the hot glue, had a logic level high. Pushed in from the side on the other side of my repair, logic level high. Scraped off a little bit of the overcoat on, well past the repair, logic level high. Get down here to the end. You can see there's a shiny spot, a little spot of copper right there. So again, I scrape through the overcoat on that, test it right there, logic level high. Test it right here, logic level low. It's like, what the heck? It'll probably never show up in the camera because it's so small. Hocus pocus, focus. Yeah, you still can't say, you might. But the trace is actually broken. Right just in slightly from where it starts, you know, it's got the overcoat on it. Yeah, you can just barely, it's right there, there's a crack the whole way across. And when this cable's plugged into the board, it's kind of flexed in that direction. So, you know, if it had flexed this way, it might actually make contact, but bent the other way, yeah, it's, so what I'm going to do is, again, I'm just going to fix it, because, like I say, you can solder on this. That's how I fix these. I'll just put a, you know, a lot of times, like this one had a piece of the trace actually missing around it. I just put a small piece of wire soldered to the terminal. I scrape off some of the solder, some of the overcoat on the trace, pre-tin that area of copper then, lay my wire down on top of it, and solder it. Now, the reason I put the hot glue on here, like I say, is to prevent the traces from breaking up here anymore, because those are very high stress areas. There's really no give. You know, so the trace comes up and it gets soldered right here. Well, that means that it can still flex a little bit, and it can't flex at the solder joint, and they can break off. So the hot glue's got a little bit of flex to it. There is a little bit of flexibility to it. And you know, it's moved that stress point back here off of the solder connections. And if I ever do need to get, or someone else would ever need to get in here, now a lot of people are thinking, oh my God, you've completely encased it in glue. It's non-serviceable now. No, it's hot glue. In case you've never seen me mention it in one of my other videos, hot glue is very easy to remove. If you know the secret is IPA, or isopropyl alcohol. I'm not a chemist, so I don't know why, but isopropyl alcohol does not dissolve the glue, but for some reason it makes it lose its bond with whatever it's stuck to. So you just saturate this with some isopropyl alcohol, come back about 30 seconds later, you come under here with your fingernail, you'll be able to just, and that whole thing will just pop off. Yeah, I don't know what IPA does to hot glue, but it just, it just loses its bond, and then you can easily take it off. So, like I said, it's still serviceable. So let me get that little broken trace there, and what I'll do is I'll take a razor knife, which is actually what I scratched through there, and I'll scrape off the solder mask off all along here. And this only actually pushes in about that far into that connector right there. So what I can do is bridge that with probably like 2 or 3 little pieces. I'll take some Kynar, really thin Kynar wire, you know, stripped. And take the little fine strands of wire and run across there, and I'll just make a little repair, a little bridge, you know, soldered on there, and yeah, that should be fine then. And as long as this thing isn't removed and installed, it should never have a problem again. Like I say, the only ones that I've ever seen broken are ones that have been removed and installed several times. Radios, I've seen radios that, my God, they look like they've been drugged behind a truck for 1,000 miles, just beat up, horrible condition. You know, radios that have seen a lot of use. And you'll take the covers off, you know, and the channel selector may even be worn out. But you look at this flat flex board, perfectly fine. Absolutely not a problem. That's because it's never flexed before. That's what kills these things. So anytime you're working on these, try to avoid sharp kinking bends, because yeah, you'll snap these little circuit traces in a heartbeat. As you can see, it does flex easily. I mean, that's why they use this. It's an easy way to make a connection, you know, at 90-degree or, you know, odd angles. But yeah, just avoid kinking it, because trust me, if you kink it, you're going to snap every one of those circuit traces. So let me get that done. As long as I get it in and that works, probably the next thing I'll do is the recap job, and we'll come back and see, you know, what else I might have found on this that it, you know, does or doesn't need, and you know, it might be done the next time I get the video fired back up here. So let me get at it. Oh, and there's a resistor hanging out here, so I've taken that tape off. All they had is that white wire goes up to actually the switch up here in the box, goes to this switch right here. There's actually 2 wires. So the one white wire connects to the trace that goes to pin 13, and you that goes into the circuit. The other white wire hooks up to the pin, or actually hooks up to pin 13 on the IC, so they've interrupted it. When it has 5 volt, around about 4.5 to 5 volts applied to it, that voltage can overcome this ground reference resistor. It's basically a dropping resistor, and it will basically set it at a high logic level. But when you remove that, you don't want to let the pin floating, so that's why you'll often see resistors when people do PLL modifications. That's actually the correct way to do it. When you're going to cut a trace and either apply voltage or take it away, the radios, the way they'll have them set up, those resistors are in circuit already. But if you're modifying it externally, and you don't want those pins floating, because that a lot of times the PLL, it'll get a floating voltage on there and it'll think it's a high when it should be low. So you want to have a pull-down resistor. That resistor then, if there is any tiny voltage on pin, say in this case, pin 13, that pulls it low, holds it at ground potential until a higher voltage source, like the actual voltage that's being applied from the channel selector switch down to it, can overcome that resistance. We'll apply the voltage to pin 13 and bumps it up to a logic high level. So let me get back to it, and actually I can see, I think that's that little green wire that went down to the underside, so that actually looks like it's part of maybe the clarifier? I don't know. Yeah, I'll have to check into this. Lots of lots of hokey and head scratching stuff here, but we'll get her figured out. Oh, and yeah, there's some diodes. I was saying, you can see them there. There's 2 diodes. They're just pulled up out of the board, not attached. So easy enough there. I just push them back down in to re-enable the limiter circuits, because the parts aren't missing. They were, the leads weren't cut off really short. They were, properly desoldered from the board, and just one end was pulled up. So that's nice. I just got to shove them back down through the holes, and that will re-enable the limiter circuit from the looks of it. So I shall return. I absolutely hate switch mods. Oh God. So I fixed the flat flex board, stuck it back in, stuck the radio on channel 20. We were good. I had channel 20. So I wanted to go through. All I want to do is, at a bare minimum, I don't care about extra channels. I just want to get channel 1 through 40. That's my main concern. It's a CB radio. It should work on channel 1 through 40. I had channel 8 through 40. I did not have channel 1 through 7. So let me put it on 1. I got my little test board in here. So what I'm going to do is just put the radio in transmit. I'm going to show you on the spectrum analyzer, and I'll tell you as I go through the channels. And you can watch the display and see as I go through. So, okay. It's over now. Up a little bit. Okay, so here's channel 1. Okay. Hope I flip the switch in the right direction. So that is not channel 1. Actually, that's 26.462 or whatever. But I'm going to flip, so there's channel 1 on the radio. I'm going to be turning the channel selector. Channel 1, 2, 3, 4, 5, 6, 7. The peak never moved at all. It's stuck on 26.426. And then I get to channel 8 and things come back to normal. 8, which is where it's supposed to be, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Now you'll see it jump a little bit more on the skip channels, because those are the A channels, so there's a channel missing in between. 21, 22, 23. Now you're going to see some jumping around here, because remember, when 40 channels came around, the missing channels between 21 or 22 and 23, they then added back in as channel 24 and 25. So you'll see there's 25 or 24, 25, 26, 27, 8, 9, 30, 1, 2, 3, 4, 5, 6, 7, 8, and 9, and channel 40. And then we get back to channel 1, and it's all screwed up again. So, what the heck? So, I figured it's something to do with the switch mod. So, again, back to the logic probe. Really simple. Went back to the SAM service manual. And I know everything channel 7 and before is wrong. Everything channel 8 and after is fine. So I wrote down what those pins should be programmed at. And actually there's one thing, if you just look at the chart, you can see what is common with every channel from channel 1 to channel 7. So look for things that are similar, that are only common on only those channels. And you can see, pin 21 changes from 7 to 8, but it's the same between, channel 1 to 7. Same thing with pin 20. It's at a high state up to channel 7, then it changes. Channel 18, no, because that stays at a 0. Again, you can see here's another one that stays the same. So, maybe there's a problem with one of those pins. So, and it's obviously probably going to be something to do with the switch mod. Probably. No guarantees. So, again, like I say, I wrote those down. So, I want to check the level, or the state of those pins. So, we'll check. I'll put the radio on channel 7. And what I should have is 00110010, starting at pin 13. So, we have low, low, low. That's correct. We should have 2 highs now. High, high. That's correct. We should have 2 lows. I think I lost count here. 13, 14, 15, 16, 17. Yeah, it was off by 1. 18 should be low, and it is. 19 is low. Pin 20 should be high. It's actually the one with this black wire. Aha! Pin 20 should be high. Pin 20 is showing as a low. So, obviously there's our problem. And like I say, that's actually not a problem. If I look then in the little, it's not a black box, it's a little blue box, but I can see both of the black wires go to this switch right here. And actually, if I flip that switch, and we go back up to look at the display here, I'll put the radio in channel 1, flip it into transmit. So there's channel 1, 2, 3, 4, 5, 6, 7. And if I go to channel 8, it goes bonkers because now I need to flip that switch in the box back down. There's channel 8, 9, 10, 11, 12, 13, and it continues on just normally. So yeah, that's all that is. That wasn't actually a problem. That was actually just the needing to figure out what all of these switches do. So yeah, that's why I hate switches. You need a road map, a big map, especially when you have this many switch possibilities. Basically every possible combination. You really need a map to be able to map out, where your channels are. There was a little chart on top of the radio, but it didn't show what you need to do to get just your straight 40 channels. So now that I know the PLL is working, the synthesizer circuit's working properly, it's receiving and and yes, I can. If I put the radio on channel 20, oh, I got all the controls turned down. You can hear, if I turn the volume up and down. So, I'm putting right there, I'm shoving, actually not a very big signal. I'm putting minus 90 dBm into it right now, so, relatively low level. Actually, let's just see how well it receives before doing anything. Let's try minus. Yeah, minus 110. It's, should be better, especially being a UPD 858 chassis. And it's still there. That's the volume at halfway. But you can still hear minus 120 dBm. Yeah, it's pretty much gone. You get down 123, 124, somewhere around there. But, so it's receiving, it's just not at the maximum efficiency, I guess you could say. So, that's good. Radio's working. Now I can recap, take care of any maintenance items. next time you see this, faceplate should be on, alignment should be done, unless I run into any other repairs I need to do I think are noteworthy and deserve a little section of video onto themselves. But yeah, otherwise I think everything's okay. So there we go. There's progress so far. Okay, as you can see, I got the faceplate back on it. Alignment's been done. So, cap's been changed, everything else, AMC, ALC, so yeah, those were completely disabled and bypassed. But I still had some horrible distortion problems. So, after I got done the recap, turned it on, checked transmit, receive was okay, but transmit, yeah, it looked, like I say, looked kind of crappy. So, yes, the couple diodes had been lifted up. Both the transistors and the limiter circuit had been removed, so I installed new transistors, reattached the diodes into circuit, and the ALC and AMC were now adjustable, but it was still distorted. It wasn't as bad as it was before, because it was adjustable, but there was still just a weird distortion. Like on AM, I'd inject 1,000 hertz into it, and instead of a nice sinusoidal waveform that came to a nice crest and then rolled back down, it would come up, you'd get a double bump. With a single tone. I'm like, what the heck? And no matter what I did, I just could not get rid of that distortion. Sideband was distorted. Actually, the second harmonic, out the RF second harmonic out of 54 megahertz range, it was a little bit higher than I'd like to see. Did not, and also did not meet the specification as far down as it should have been. And then I finally noticed what was wrong. This radio has two finals, or it had two finals, and I don't mean that the radio had dual finals. No, it had a 2SC1307 for a final, and a 2SC1307 for a driver. At some point in time, someone had installed a final transistor. Well, it's just a transistor. It could be used for anything, but they installed the transistor that should be used as a final in this radio, and they installed this as a driver. Now, it worked. Like I say, it was distorted for starters. Once I put the proper 2SC1306 in this, which it's supposed to have, got the bias adjusted on the driver and the final, adjusted the transmit circuitry, linearity came back, it was clean. So the problem with doing something like this, putting a transistor, because a lot of people will think, well, this is a higher power device, which it is. The 1306, I think, is like a 10-watt device. I think this is 16 watts. The thing you have to realize is you don't need 16 watts coming out from your driver stage into the final. If you did feed, 16 watts into a 1307, you can pretty much be guaranteed you're going to let the smoke out of it. So the biggest problem there is it's the gain. This transistor may have a higher, may be able to produce a higher power, but this transistor also has a lower gain. Because you have to realize it's a very small transistor, relatively speaking, the pre-driver that amplifies the signal before the driver. So the driver needs to have a lot higher gain than the final transistor does. Honestly, there's very little gain. If you consider the gain of a lot of transistors, you can have huge gains. 200, 300, 400. HFEs. Just massive gain. Little tiny signal going in, massive signal coming out. Final transistors, you're not going to see that. You're going to have a relatively small signal. Something like maybe a watt feeding into this transistor, and then 4 or 5 watts maybe coming out or something like that. It's a very small power gain usually. You're not looking for multiplications of 10 times, 50, 100 times power. It's very small. And that was the problem. Putting this transistor in place of the driver transistor had the gain all screwed up. It's also that entire circuitry, none of the components were changed. The transistors were just changed, and the entire driver circuit was just left the way it was supposed to be. So the problem there again is it's not going to be I guess you'd call that wave shaping, because if you ever take an oscilloscope and you go through any circuit, doesn't need to be, a driver and final transistor. But if you're looking at something that has amplification in stages, look at the input signal and the output signal, especially on like a driver and a final, because they're easily visible on, even a pre-driver. They're easily visible on an oscilloscope because they are very, very large signals. But look at what they look like. They're horribly distorted. They look nothing like what's coming out of your antenna jack. What comes out of your antenna jack when you key your microphone, with no modulation, ideally it should be a perfect waveform at whatever channel you're on, for that frequency, and no harmonics, if the radio is well designed. If you hook up to the output of the final transistor or the driver transistor or the pre-driver transistor, it's not going to look like that in any way, shape, or form. It's going to look all deformed. You'll see sometimes there'll be hardly anything in the negative region. It'll all be this distorted looking signal. That's because it gets wave shaped as it goes through all the filter networks and whatnot in the radio and in between the coupling stages in between the stages. So yeah, that's what caused that. So if someone tells you, hey, yeah, I can just take a final and another final and put it in place of your driver and get more power, honestly, probably what you're going to get is less power. Now, some of the modern radios, and I mean like current production radios, they're using MOSFETs, and they'll use like a IRF 520 for the driver and for the finals. That's fine if the radio was designed around those MOSFETs. It was designed to use an IRF 520 as a driver. This radio was not, so just dropping in some basically random transistor, because that's basically what you're doing. If you're using anything other than what was designed to be in it, you're basically just picking a random transistor and plopping it into the circuit and hoping for the best. So yeah, I took that out. Now, there's nothing wrong with this transistor, so I'll put it in an envelope, I'll tape it to the top of the radio, and the customer can have this back, because they haven't made these for decades, just like the 1306s. I have new ones. Lots of new old stock for both of them. But yeah, there's nothing wrong with this transistor, so he can keep this as a spare for the final in this radio. So, but yeah, other than that, yeah, it's got some other little modifications. It's kind of like, because this thing, honestly, it had a lot of work done to it over the years. A lot of work. And yeah, just some of the stuff was, now like I say, limiting circuits, they've all been re-enabled. I got a few blobs of hot glue actually holding these cables down so they're not flopping around in there anymore. And like I said before, you get hot glue off, just put a little bit of isopropyl alcohol on there and boink, it'll just pop off. So, servicing's not a problem if anything ever needs to be, component needs to be removed under here or something. So there you go. All I got to do now is clean the covers up, put them back on, and this radio will be another UPD 858 chassis, resurrected and ready to be put back on air.